गुड इवनिंग एवरीवन। सभी का स्वागत है एक बार फिर से इस प्लेटफॉर्म पर जिसका नाम है वन मार्क सोल्यूशन। और जैसा कि आपको पता है कि इस प्लेटफॉर्म पर आपको हर चैप्टर का हर सब्जेक्ट के हर चैप्टर के 1 मार्क के जो क्वेश्चंस है, जो OTQs आते हैं, जो मल्टीपल चॉइस क्वेश्चन है, ट्रू फॉल्स है, सक्सेशन रीजनिंग के जो क्वेश्चंस हैं और इस तरीके के और जो भी डिफरेंट क्वेश्चंस जिनको कि 1 नंबर में CBSE एग्जाम्स में पूछता है या आपके जो कॉम्पिटिटिव एग्जाम्स में जो क्वेश्चंस आते हैं उनको हम यहाँ पर 1 मार्क क्वेश्चन के इस प्लेटफॉर्म पर जो है वो डिस्कस करते हैं आपके साथ में, सब्जेक्ट एक्सपर्ट्स के साथ में। जो सब्जेक्ट एक्सपर्ट्स होते हैं हमारे, वो सब्जेक्ट एक्सपर्ट यहाँ पर हमारे साथ जुड़ते हैं और उस पर्टिकुलर चैप्टर से जितने भी क्वेश्चंस जो है वो 1 नंबर में पूछे जा सकते हैं, उन सभी तरह के क्वेश्चंस को यहाँ पर हमारे सब्जेक्ट एक्सपर्ट्स जो है वो इन डिटेल डिस्कस करते हैं कि कैसे आप ये पहचानें कि किस पर्टिकुलर क्वेश्चन का कौन सा पर्टिकुलर आंसर जो है वो करेक्ट है और कैसे आप उसको चूज करें। आज हम डिस्कस करने वाले हैं फिजिक्स का चैप्टर 9 का पार्ट 2, रे ऑप्टिक्स का पार्ट 2 हम लोग डिस्कस करने वाले हैं। डिस्पर्शन एंड जो इक्विपमेंट्स है उसके बारे में आज हम लोग यहाँ पर डिस्कस करने वाले हैं। और आज हमारे साथ सब्जेक्ट एक्सपर्ट के रूप में स्टूडियो में हमारे साथ हैं हितेन परमार सर। हितेन सर, आपका बहुत बहुत स्वागत है इस प्लेटफॉर्म पर। और जैसा कि हमारे जो व्यूवर्स हैं उनको पता है कि हितेन सर पिछले कई सेशंस हमारे इस प्लेटफॉर्म पर जो है वो बच्चों के साथ डिस्कस कर चुके हैं और आज हितेन सर का ये प्रोबेबली 5वां जो है सेशन है इस प्लेटफॉर्म पर। और आज ही हमारे साथ डिस्कस करने वाले हैं फिजिक्स क्लास 12 के लिए चैप्टर 9 रे ऑप्टिक्स का पार्ट 2, डिस्पर्सन एंड ऑप्टिकल इंस्ट्रूमेंट्स। तो निश्चित रूप से फिजिक्स एक ऐसा पार्ट है, फिजिक्स एक ऐसा सब्जेक्ट है जो आपके नीट में भी काम आता है, आपके जेई में भी काम आता है और आपके इंजीनियरिंग के अदर जो एग्जाम्स होते हैं उनमें भी काम आता है। तो निश्चित रूप से और सबसे ज़्यादा जो कंफ्यूजन होता है, सबसे कम मार्क्स अगर देखे जाए तो बच्चों के फिजिक्स में स्कोर होते हैं। लेकिन मुझे ऐसा लगता है कि आज हमारे एक्सपर्ट यहाँ से जो ये चैप्टर डिस्कस करेंगे आपके साथ, इस चैप्टर को पढ़ने के बाद, सुनने के बाद, इस वेबिनार को अटेंड करने के बाद आपके इस चैप्टर से रिलेटेड सभी क्वेश्चन, सभी डाउट्स जो है वो पूरी तरह से क्लियर हो जाएंगे। हितेन सर इज वर्किंग एज अ PGT फिजिक्स इन माय ओन स्कूल जयपुर राजस्थान। और सर CBSE के साथ भी जुड़े हुए हैं। CBSE की जो वर्कशॉप होती है, जो ट्रेनिंग वर्कशॉप होती है, टीचर्स ट्रेनिंग वर्कशॉप होती है, कंटेंट क्रिएशन की वर्कशॉप जो होती है, उनमें भी सर हमेशा रहते हैं। और बहुत सारा कंटेंट CBSE के माध्यम से जो स्कूल्स को अवेलेबल कराया जाता है, बच्चों को अवेलेबल कराया जाता है, उसमें इनका एक बड़ा योगदान हितेन सर का है। हितेन सर, मैं ज़्यादा समय नहीं लेते हुए आपको हैंड ओवर करता हूँ कि आप सेशन कंटिन्यू करें प्लीज।
गुड आफ्टरनून एवरीवन। कल हम लोग रे ऑप्टिक्स का पहला पार्ट, जिसमें रिफ्लेक्शन एंड रिफ्रैक्शन के बारे में हमने बात करी थी, वो हम लोग पूरा डिस्कस कर चुके हैं। टुडे इन द सेकेंड पार्ट ऑफ इट वी आर गोइंग टू टॉक अबाउट डिस्पर्जन। डिस्पर्जन में आई हैव इंक्लूडेड प्रिज्म रिलेटेड ऑल द थिंग्स। उसमें कहीं थोड़ा बहुत TIR, ग्रेजिंग अलोंग द सरफेस की बात भी हो जाएगी, एंड ऑप्टिकल इंस्ट्रूमेंट्स। सर, स्क्रीन शेयर हो रही है?
जी सर, हो रही है।
अगर हम लोग इसमें इंपॉर्टेंट पॉइंट्स टू रिमेंबर की बात करें, क्या क्या चीजें हमारे को ध्यान रखनी है, अगर हम उसकी बात करें तो सबसे पहले वी आर गोइंग टू टॉक अबाउट रिफ्रैक्शन थ्रू अ प्रिज्म। प्रिज्म का जब हम लोग रे डायग्राम बनाते हैं, आज थोड़ा सा हम लोग एक्सप्लेनेशन पार्ट पे ज्यादा हैं, क्योंकि इसमें क्वेश्चंस जो हैं वो इतने डेप्थ पे क्रिएट होते हैं कि इट इज बेटर टू अंडरस्टैंड द कॉन्सेप्ट्स। हाँ, क्वेश्चंस भी रखे हैं, बट थोड़ा सा एक्सप्लेनेशन पार्ट भी ज्यादा है। रिफ्लेक्शन थ्रू प्रिज्म का जब हम लोग ड्रॉ करते हैं तो इसमें आप लोगों को क्या क्या चीजें ढंग से बनानी है, और इनमें से किसी भी एक चीज को लेके क्वेश्चन क्रिएट कराया जा सकता है इन 1 मार्क। एंगल ऑफ इंसिडेंस, एंगल ऑफ इमर्जेंस, जो रे एंटर करती है उसका नॉर्मल के साथ, जो रे निकलती है उसका नॉर्मल के साथ एंगल। द एंगल ऑफ प्रिज्म, जो प्रिज्म का सबसे ऊपर टॉप मोस्ट वर्टेक्स एंगल होता है, दैट इज एंगल ऑफ प्रिज्म, दैट इज ऑलवेज रिप्रेजेंटेड बाय ए। रिफ्रैक्शन के 2 एंगल्स R1 एंड R2, एंड द मोस्ट इंपॉर्टेंट इज द एंगल ऑफ डेविएशन डेल, जिस पे सबसे ज्यादा क्वेश्चंस बनते हैं। ऑलवेज व्हाइल carrying out the calculations or substituting the values or presenting your answers, you should remember angle of incidence and angle of emergence का sum angle of prism and angle of deviation के बराबर होता है. This relation I plus E is equal to A plus del is also known as prism equation, and the angle of prism A is always equal to R1 plus R2. AC surface के लिए mu sin I by sin R1 होगा. Rarer to denser का केस है. For surface AB जब ray of light वापस बाहर आती है, denser to rarer है, तो वहां पे refractive index mu sin R2 by sin E के फॉर्म में दिया जाएगा. For a thin prism, the angle of deviation del, जो सबसे ज्यादा हम लोग MCQ में क्वेश्चंस यहाँ इस पोर्शन से एक्सपेक्ट करते हैं, वो इस फॉर्मूला del is equal to mu minus 1 A पे डिपेंड करता है. Mu is the refractive index for the prism. I think you all know कि अगर refractive index कभी किसी भी लाइट या किसी मटेरियल के लिए दिया होता है, it is only for yellow light until unless no other color is mentioned. Even if you say that refractive index for white light is, then that also is for yellow light, because yellow is the average color of the spectrum. हर कलर के लिए अलग refractive index होता है. So del is mu minus 1 into A, angle of prism. We can say that जब जब angle of prism A बढ़ता है, एंगल ऑफ डेविएशन बढ़ेगा. क्वेश्चंस मेनली म्यू पे ज्यादा रहेंगे. इसमें भी अगर रिफ्रैक्टिव इंडेक्स बढ़ता है तो डेविएशन भी बढ़ता रहेगा. अगर रिफ्रैक्टिव इंडेक्स की बात करें, रिफ्रैक्टिव इंडेक्स विबग्योर जो आपका विजिबल स्पेक्ट्रम है, जो व्हाइट लाइट है, उसमें इट इज मैक्सिमम फॉर वायलेट एंड मिनिमम फॉर रेड. एंड बिकॉज ऑफ दैट नाउ वी कैन से दैट एंगल ऑफ डेविएशन भी मैक्सिमम फॉर वायलेट एंड मिनिमम फॉर रेड क्रिएट होगा. ग्लासेस में दो तरह के ग्लास की बात होती है. वन इज फ्लिंट ग्लास एंड अदर इज क्राउन ग्लास. क्राउन ग्लास बेसिकली जो ज्यादा क्लियर, ज्यादा ट्रांसपेरेंट, जिसको हम लोग इटालियन क्रॉकरी या बहुत ज्यादा कॉस्ट वाले महंगे ग्लासेस होते हैं, उसके लिए हम क्राउन ग्लास वर्ड यूज करते हैं. और जो नॉर्मल एवरेज ग्लास होता है, दैट इज फ्लिंट ग्लास. फ्लिंट ग्लास, एज यू ऑल नो, इज लेस ट्रांसपेरेंट एज कंपेयर टू द बेटर क्वालिटी और द कॉस्टली ग्लासेस, द क्राउन ग्लास. तो उसका रिफ्रैक्टिव इंडेक्स भी फ्लिंट ग्लास का ज्यादा होगा. तो फ्लिंट ग्लास, इफ इट इज having higher refractive index than the crown glass, so of course it would also have higher angle of deviation than the crown glass. Minimum angle of deviation पे questions बनते हैं. Minimum angle of deviation का फिगर जब भी हम लोग ड्रॉ करते हैं, तो उसमें as mentioned over here, you have to remember that the ray inside the prism is always parallel to the base of the prism. जो सेकेंड पॉइंट दे रखा है आपको. एंड I एंगल ऑफ इंसिडेंस, E एंगल ऑफ इमर्जेंस, दोनों बराबर होंगे. एंड इफ I and E आर इक्वल, देन R1 R2 भी बराबर होगा. एंड R1 R2 दोनों जो बराबर होंगे, उसकी वैल्यू एंगल ऑफ प्रिज्म A से आधी आ जाएगी अपने आप ही. R is equal to A by 2. एंगल ऑफ इंसिडेंस का फॉर्मूला तो उसमें बन जाएगा A plus del M, the minimum angle of deviation that we are going to get in this case, whole upon 2. तो म्यू का फॉर्मूला sin I अपॉन sin A by 2, sin I by sin R A by 2 है. then you will get mu as sin of A plus del M by 2 upon sin A by 2. This formula mu is equal to sin A plus del M by 2 upon sin A by 2 is known as prism formula if ever asked. एक कंडीशन है जो बहुत ज्यादा MCQs में यूज करी जा सकती है. if minimum angle of deviation is equal to the angle of prism, then the refractive index would always be equal to 2 cos A by 2. And the graph there is also associated with it. The graph is many times asked as one of the 4 options. Minimum angle of deviation का graph है, and where the angle of deviation is least, where del M is there, there I has to be equal to E. If a ray of light is normally incident on a prism, that means if it is perpendicular to one of the face, then in such cases mu would always be equal to sin I by sin A, and angle of deviation del would be equal to I minus A in either of the 3 cases. Suppose it is normal at the first face, suppose it refracts from the first face, and it is normal at the second face. If even one of the face is mirrored, polished from outside, even then this relation exists true. Ever, if any ray in case of a prism is normal to any of the face, then mu is equal to sine I by sine A, and del is equal to I minus A. Angle of incidence would be at any of the face where it makes any angle other than 90 degree. Normal incidence, angle of prism A, if C is critical angle, this is a special case of normal incidence where we are going to discuss a bit of TIR as well. If A is angle of prism and C is a critical angle for the material of prism, you know sin C is equal to 1 by mu. Ray 1, 2 and 3 are given. Ray 1 would be the case of general emergence, and it would be when the angle of prism is less than the critical angle. And in this case, the refractive index would be less than 1 by sine A, that is less than cosec A. Grazing emergence, that means when it grazes along the surface, it would be when A is equal to C, and TIR would occur when A is more than the critical angle C. The case is we are talking of when A, the angle of prism, and C, the critical angle, are related as A is less than C, A is equal to C, or A is greater than C. For grazing emergence, the minimum angle of incidence needed is sine inverse of mu square minus 1 sine A minus cos A. This formula can be used directly in questions for MCQ, not in CBSE explanations. That is to be remembered. Now coming to dispersion. Dispersion, the phenomena of splitting of white light or any color into its constituent components, constituent colors. That is what is known as dispersion of light. And as we have already discussed, when a white ray of light falls on a prism, violet shows maximum deviation, red shows least deviation. The vibgyor formed is from bottom to the top. Violet is the bottommost color in the vibgyor, and red is the topmost color in the vibgyor. When rainbows are formed, the primary rainbow is of this kind. If the violet is on the topmost part and red is on the bottommost part, then it is secondary rainbow. And if both the ends are violet and red is the middle zone, then it is a combination of the two rainbows, dual rainbow we can call it. Angular dispersion. Angular dispersion, if you can see in the bottommost figure over here, is the angle between the red dispersed ray and the violet dispersed ray. The angle of spreading of the spectrum vibgyor, that is known as angular dispersion. Angular separation between the extreme colors is angular dispersion, and it is given by angle of deviation of violet minus angle of deviation for red. And if you apply that formula, del is equal to mu minus 1a, you get the angular dispersion theta is equal to mu v minus mu r, refractive index for violet color minus refractive index for red color, into the angle of prism A. So we can say that angular dispersion depends on the refractive index of the prism and the angle of the prism. Dispersive power is a very much talked of formula or part in MCQs, and it is given by angular dispersion upon the average angle of deviation. Average angle of deviation, I told you that yellow is the average color of the spectrum. That is angle of deviation for the yellow color. Substituting the formula and the values, we get dispersive power omega is equal to mu v minus mu r upon mu minus 1 or mu y minus 1. It is mentioned over there, mu y is mu v plus mu r by 2. You can take it in that manner as well. It depends only on the material of the prism, that means mu. In the formula for dispersive power, nothing other than the refractive index is mentioned. So it depends only on the mu. Angle of prism is nowhere going to affect the dispersive power of the prism. And dispersive power of flint glass, that is the glass having comparatively less transparency, is always dispersive power of less transparent material is more than dispersive power of a better or more transparent material. Two more headings are talked about over there in combination of prism. Dispersion without deviation and deviation without dispersion. Dispersion without deviation it somewhere or the other means that no deviation is present. That means net del is equal to 0, and it represents that a spectrum is emerging out of the combination of the two prisms, but the yellow color of the emerging VIBGYOR, the emerging spectrum, is parallel to the incident ray, that we call dispersion, colors being spread out without deviation. The final color, light yellow, is parallel to the incident color of light yellow. And these conditions are present. The two formulas mentioned, A dash upon A dash is the second prism, A is the first prism, is equal to mu y minus 1 for the first prism upon mu dash y minus 1, that is for the second prism. Similarly, deviation without dispersion is talked of. That means only one ray of light is moving out, only white light is resulting from the second prism, but it is not parallel to the incident ray. That means the deviation is occurring, but dispersion is not taking place. And there A dash upon A is equal to minus of mu v minus mu r upon mu dash v minus mu dash r. You can note down these formulas for direct use in MCQ questions or one marker questions. Today, most of the questions are going to be MCQ because that is what appears from this region. A very small region other than dispersion and optical instruments that many times comes as a conceptual question in MCQs is scattering of light. Scattering means molecules of a medium, after absorbing the incoming light radiations, emit them back into all directions. They absorb and re-emit all around. This is what is scattering of light, and that is why our atmosphere is visible to us. That is why things are visible to us. In chemistry also, we have studied or discussed this topic of scattering in terms of Tyndall effect. Rayleigh, he told us about it, and he said that the intensity of scattered light is inversely proportional to the fourth power of wavelength, fourth power of lambda. That means if lambda is more, the scattering amount, the intensity of scattering would be less. Red color has maximum wavelength of the 7 colors of the VIBGYOR. So scattering would be least, and that is why we make danger signals as red. It does not get scattered much, so it has the capacity or capability to travel larger distances. It can be looked on, it can be observed or identified even when fog or smoke is there, even when visibility is less, because the scattering is least. The ray of light stays concentrated in form of a beam and travels larger distance with more efficiency, and that is why danger signals are red. That is why in the morning and evening, the sky appears to be a bit reddish to us because the comparative distance is more. And in the daytime, it appears to be blue because we are in the region where blue color is scattering the most. Scattering are of two different kinds as well, elastic and inelastic scattering. I have mentioned it over here just because the inelastic scattering was explained by one of the Indian scientists, and it has been observed in the past that in our competition exams or our board exams, if anywhere related to an Indian person is we can think of, then it has a greater probability of appearing in the exams. That is why just I have mentioned it over here. Elastic scattering is when the wavelength of radiation remains unchanged even after scattering. And inelastic scattering is where under specific conditions the light can also suffer a phenomenal or a remarkable change in its wavelength. Raman, so C.V. Raman, he told us about it, and it is known as Raman's effect, and that is why it comes to be an important part of for the MCQ exams. Now coming to the questions from the prism region and scattering region. When light rays are incident on a prism at an angle of 45 degree, minimum deviation is obtained. Minimum deviation when I is equal to 45. If refractive index of the material is √2, wherever √2 appears, you should always get it in your brains that sine 45 and cos 45 is 1 by √2. It has something to do with that part. If refractive index of the material of prism is √2, then angle of prism will be 30, 40, 50 or 60. The formula mu is equal to sine I on sine A by 2 is being used over here. If mu is root 2 and I is 45, sine 45 you substitute to be as 1 by root 2 and you get your answer as sine A by 2 is equal to half, or A by 2 is 30 because sine 30 is half, and we get A is equal to 60 degree. The D option is over there. Angle of minimum deviation for a prism of refractive index 1.5 is equal to the angle of prism. Angle of minimum deviation del is equal to angle of prism A. The angle of prism is, it is given in the question that cos 41 is equal to 0.75. If I would have been a student over there, somewhere or the other, it is very clear if cos 41 is given, 41, 82, or 90 minus 41, that is 49. These have to be my answer. Otherwise, this value cos 41 is not to be provided in the question. If it is provided, the answer has to be related to that particular angle. And here the answer, now two options are left for me, B or C. If I'm not having time, I'm going to take out either of these. But now look at the question. Angle of minimum deviation is equal to angle of prism. Del M is equal to A. The formula, prism formula, mu is equal to sine A plus del M by 2. A plus A by 2, 2A by 2, that is sine A is the numerator. Sine A by 2 is the denominator. Sine A can be written as 2 sine A by 2 cos A by 2. So I cancel it out and get 2 cos A by 2 is equal to mu. The value of mu is given as 1.5. 1.5 is equal to 2 cos A by 2. Solve it. You will get cos A by 2 is equal to 0.75. The given value cos 41 is 0.75. So A by 2 is 41 and A is equal to 82. Option C is the correct answer. Angle of glass prism is 60 degree and the refractive index of the material of the prism is 1.414. 1.414. Again, they are indicating root 2 in the question. Then what will be the angle of incidence so that ray should pass symmetrically through prism? Looking at the four options, my answer is going to be C. I'm not going to even solve it if I am over there because we are not in a situation in any of the exams to calculate the trigonometric ratios of 38 degree, 61 minute, or 35 degree, 35 minute, or 53 degree, 8 minute until unless it is not presented in the question. In the last question, we had given you the value of cos 41 as 0.75. Here it is not provided, so there is no chance to get an answer other than 45 degree. And you can look at the solution as well. Incident ray and emergent ray are symmetrical in the given question when prism is in minimum deviation position. So in this condition, mu is sine I by sine A by 2. Sine I has to be mu into sine A by 2. Mu is given as root 2 and A is 60. So sine I is root 2 into sine 30, that is 1 by 2. Root 2 into 1 by 2, that is 1 by root 2, and I comes to be 45. As I told you, there was no other option possible in this particular question other than root 45 degree. If prism mu is equal to 1.5 has a refracting angle of 30 degree, the deviation of a monochromatic ray incident normally on its one surface will be, now again an angle is given, 48 degree and 36 minute. So we have to think of which options are possible in it. 90 minus 48 degree 36 minute, or the angle 30 and 48 degree 36 minute. No other options are visible. I can see 48, 36 minus 30 is 1836. So don't go with the solution, mark 1836 in it as the answer. And see, the solution is provided to you as well. The answer is 18 degree and 36 minutes only. Mu is sine I by sine A, and there we get sine I is 0.75 and I is 48 degree and 36 minute. Daily is I minus A, 48, 36 minus 30, 1836 is the answer. So in such questions where angles other than 30, 45, 60, 90 are provided, we can just get the answer by elimination options as well in the MCQ part. Angle of prism is 30 degree and its refractive index is √2. One of the surface is silvered. At what angle of incidence a ray should be incident on one surface so that after reflection it retraces its path? If after refraction, if after reflection the path is to be retraced, then the ray has to fall normally on that particular surface. Light ray is falling normally on the second surface. So by using it, the formula mu is sine I by sine A. √2 is sine I by sine 30. Sine I is 1 by √2 or I is 45 degree. The refracting angle of prism is A and refractive index of material of prism is cot A by 2. What is the minimum angle of deviation in this case? And minimum angle of deviation is now expressed in terms of 180 or 90 plus minus something. How to get to these things? Simply use Prism formula if nothing else you can think of. Prism formula says mu is equal to sine A plus del m by 2 upon sine A by 2. Refractive index is given as cot A by 2. Cot A by 2 means cos A by 2 upon sine A by 2. The two denominators gets cancelled. Sine A by 2 and sine A by 2 gets cancelled. And we get that cos A by 2 is equal to sine A plus del m by 2. One side is having cos, the other is having sine. So cos A by 2 can be written as sine 90 minus A by 2. Sine 90 minus A by 2 is equal to sine A plus del m by 2. 90 minus A by 2 is equal to A plus del m by 2. So we can get that del m is equal to 180 minus 2A. Option D is correct in this case. A ray of light passes through an equilateral glass prism in such a manner that the angle of incidence is equal to the angle of emergence, and each of these angles is equal to 3 by 4 of the angle of the prism. Angle of incidence is equal to angle of emergence. That means it is about the condition of angle of minimum deviation. And if this is the angle of minimum deviation were the case, then we know that I is equal to E and the R is equal to R and R is equal to A by 2. So that all conditions are to be applied over here. A is given as 60 degree. Equilateral glass prism. All angles are 60 degree. So A by 2 is 30. I is equal to E is equal to 3 by 4A. That is 45 degree. I and E are given as 45. A is given as 60. Del can very easily be calculated by substituting the values. 45 plus 45 is equal to 60 plus del. 90 minus 60, that is del is 30 degree. PQR is a right-angled prism. Look at the figure in which PQR is a right-angled prism and the two other angles are given as 60 degree and 30 degree. The refractive index of the prism is 1.5. The hypotenuse side, the PQ side, has a thin layer of liquid above it and light falls normally on the surface PR. For TIR, what should be the maximum refractive index of the liquid? The angle of incidence theta in this case has to be 60 degree. Always the angle of incidence in such cases when the ray falls normally is the angle made by the one end of that particular face, that is 60 degree. Theta is 60 degree in this case. So for grazing along or for TIR, the critical angle has to be less than 60, or sine C has to be more than sine C. Sine 60 has to be more than sine C. Sine 60 means root 3 by 2 has to be more than sine C. Sine C means the ratio of refractive index of the liquid and the prism. And from this we can get that mu of liquid, the refractive index of the liquid, should be less than the value of root 3 by 2, the value of sine 60 root 3 by 2, and the refractive index of the prism into 1.5, and you get the answer as 1.3. So refractive index has to be less than 1.3. So 1.3 is the maximum value of refractive index of the liquid that should be over there above the surface PQ. There are two identical prisms, 1 and 2, each with angles of 30 degree, 60 degree and 90 degree placed or arranged as shown in the figure. A ray of light passes through the combination in the position of minimum deviation. These two collectively would be acting as a single prism with apex angle or angle of prism as 60 degree, an equilateral prism I can call it. Minimum deviation, that means the ray inside has to be parallel to the base, and it suffers a deviation of 30 degree. If the prism 2 is removed, then what would be the angle of deviation? Dale is equal to mu minus 1 into A is a simple straight formula. Now if A is halved, mu is not going to change. Dale is directly proportional to A. So if the angle of prism A is halved, the angle of deviation Dale would also be halved. If initially the angle of deviation was 30 degree, now it would be half of that, that is 15 degree. Option A would be the correct answer in this case. Next question is, a ray of light is incident to the hypotenuse of a right-angled prism after traveling parallel to the base inside the prism. A ray of light is incident to the hypotenuse of a right-angled prism after traveling parallel to the base inside the prism. If mu is the refractive index of the material of the prism, the maximum value of the base angle for which light is totally reflected from the hypotenuse is light being totally reflected, that again we are talking about TIR. If alpha is the maximum possible value of the base angle for which TIR occurs at the hypotenuse, then the critical angle should be equal to, as I told you, the above angle 90 minus alpha. So C is equal to 90 minus alpha. The minimum value for angle of incidence on the hypotenuse for TIR is 90 minus alpha. Sin 90 minus alpha, sin C has to be equal to 1 by mu. Sin C is 1 by mu and C is 90 minus alpha. So alpha has to be equal to cos inverse. Sin 90 minus alpha is cos alpha. Cos alpha is 1 by mu. So alpha is cos inverse 1 by mu. Next question, the light is incident at an angle of 60 degree on a prism, of which the refracting angle of prism is 30 degree. The refractive index of material of the prism would be I plus E is equal to A plus Dale. I is given as 60. A and Dale are 30 in this case. Light is incident at an angle of 60 degree on a prism. Of a refracting angle of the prism is 30. So A and Dale both are 30. So from this we get that the angle of emergence is 0. That means the emergent ray would be moving normally. That means the ray incident on the second surface falls at an angle of 90 degree on it. So mu is sin I by sin A. Sin I is 60. A is 30. Sin I by sin A is root 3. D option is your correct answer. This is what was about dispersion or prism cases. Scattering generally is the theoretical part. The things that we discussed can always be converted into one markers. Not talking about optical instruments, and from the foremost optical instrument of these is our human eye. I can create a statement or a phrase over there. The optical instrument required to use any other optical instrument is the human eye. Human eye is one such optical instrument. If it is not there with any human, with any person, they cannot use any of the other optical instruments such as binoculars, telescope, microscope. आँख ही नहीं होगी तो आप इन optical instruments को use नहीं कर सकते. There are various parts of this human eye that we should be knowing about. Starting from the front and moving towards the back, the frontmost part of human eye is cornea, the bulged out portion. That is a transparent part that protects our eye from external effects such as wind or insects or dust and all, protective layer, and that is kept moist by the aqueous humor, a material of refractive index around 1.35 behind the cornea. Its function is to keep the cornea moist. We all know that if the cornea starts getting drying, disease such as known as cataract, a cloudy or a salty layer being formed, that is drying of aqueous humor causes it, and cataract is a medical issue. Cataract removal is an operation that generally takes place in higher ages or aged persons, but nowadays it is observed in small kids as well, but that is an abnormality. Behind the aqueous humor is the eye lens, a convex lens, a converging lens made up of dead cellulose proteinous materials produced within the human body only, a very flexible convex lens whose focal length can be changed with the help of ciliary muscles that are connected with the eye lens with the help of suspensory ligaments. And contracting and expanding of ciliary muscles changes the focal length of the human eye, giving us the accommodation power. Behind the eye lens is vitreous humor. Eye lens is of refractive index 1.36 or 1.37. Vitreous humor again of refractive index 1.36, 37 or 38. Aqueous humor, eye lens and vitreous humor are gradually increasing refractive indices. Vitreous humor is a jelly-like material and it is there to keep the eye lens in its position and to keep the spherical shape maintained of the eyeball. Sclera is the outermost layer of the eyeball and the inner portion is having the retina on it. Between sclera and the retina, the layer, it has membranes. Between these two membranes are present the optic nerves that takes the message to the brain. Yellow spot and blind spot are two regions on that retina. If the image is formed on the yellow spot, best possible sharp and focused image is observed. And if the image is formed on the blind spot, no optic nerves are there and the image is not transferred at all to the brain. Always remember the image formed within the human eye is inverted in nature and our brain re-inverts it or makes it erect for understanding purpose. This is somewhat more mentioned over there. The eye lens as an average behaves as a material of refractive index 1.437. Retina, yellow spot, blind spot, ciliary muscles, this all I have mentioned over there and I've explained it to you in the figure. The range of vision of the human eye, the near point, the least distance where we can look at the things with ease is 25 centimeter. That is why from the childhood you are being told again and again that you should keep the books and the material that you are reading to or looking at least at a distance of 1 foot from your eye. It is actually a bit less than 1 foot, 25 centimeter. And the farthest point that we can look at with ease is at infinity. We can look at far off objects with ease. So the range of vision for a human eye is 25 centimeter to infinity. A normal eye can see objects clearly between the range 25 centimeter to infinity. And this 25 centimeter, that is also known as least distance of distinct vision, is more generally referred to as capital D. It is represented as capital D in various concepts and various formulas. Here I would like to mention that for a newborn baby, the least distance of distinct vision is less than 10 centimeter. But with the growth of eye, it goes and settles at 25 centimeter. Persistence of vision, it is 1/10th of a second. Persistence of vision means the time interval between two consecutive light pulses. I cannot distinguish between two images that are at a distance or at a time less than that. And that is why many a times when images are run fast in front of us, they appear to us in form of a movie. There is nothing known as video or movie in science. These are consecutively taken images running at a very fast pace. The persistence of vision of 1/10th of a second is made use of it over here. Binocular vision means looking at objects with two eyes, resolving limit, the ability to observe two distinct points easily. Something about defects in eye, myopia and hypermetropia. Theoretical one-mark questions can appear from it. Distant objects are not seen clearly, then it is myopia. Closer objects, if they are not being seen clearly, then it is hypermetropia. The images are formed in front of retina in case of myopia and behind retina in case of hypermetropia. Far points gets reduced in myopia. Near point moves away from us. More than 25 it is over there, then it is hypermetropia. The reasons, remedies, how it can be removed. Concave lens is used for removing myopia and convex lens is used for removing hypermetropia. The numericals for it we can talk of in the questions. Two more diseases that we are going to talk is presbyopia, a combination of two defects in which myopia and hypermetropia act all together. They are known as presbyopia. Generally after the age of 40-42, everyone has a dual power spectacles or lenses on, bifocal lens, and that is because they are suffering from presbyopia. Astigmatism is a very less talked about defect of human eye. There are many more defects such as night blindness and color blindness and all that we generally not talk about in physics. Very less we talk about it in physics. At least it does not appear in MCQs. It comes to be there in theoretical questions. So that I have not mentioned over here. Astigmatism, where the ruled lines of a notebook or the lines of a graph paper or a wire mesh, the window mesh, khirki ki jali that you have around you, it does not appear to as parallel horizontal and vertical lines to us. If you can recall, when you go to an optical shop or when you go to an eye specialist and they start checking your number, many a times you read HSK or you read ASH, you read DSO, or you might have seen your parents or your brothers, sisters when they are checking or finding out the power or the number of their eyes. This sort of issue is created, and you just look at it, why the person is looking at D and he is reading as O. Why A is being read as H, or why such sort of variations are being created? That is because of this disease, astigmatism. You are not able to identify horizontal and vertical lines as horizontal and vertical lines. They appear to us as bent or curved lines. And that is because your eye lens is not perfectly vertical in your eye. The eye lens, due to one reason or the other, has got a bit tilted, and that is what is known as astigmatism, and it is removed by using toric lenses or cylindrical lenses. If the number of the human eye, the power of the human eye, is having any cylindrical excess number in it, it is astigmatism that is being cured for. And if it is having spherical number only, then it is purely hypermetropia or myopia. If the power is negative, अगर minus का चश्मा लगता है, then it is myopia. एंड अगर प्लस का चश्मा लगता है then it is hypermetropia. A concave lens is used for myopia. A concave lens has negative focal length and power is 1 by f. So 1 of a negative number, 1 upon any negative number has to be negative. Everyone at your age, at student age or age below 30, 35, they generally suffer from myopia only. There are two optical instruments that we are going to discuss over there in this class 12 curriculum. One is microscope and the other is telescope. Microscope having a magnifying power of beta upon alpha. Magnifying power is the ratio of visual angle with instrument of the image upon visual angle with instrument at least distinct vision of the object in the line of image, if I go to very accurate statement for there. So simple microscope, that is simply a convex lens, a magnifying glass. Its magnifying power, its magnification, when image is formed at d is 1 plus d by f, that is a maximum magnification, and it is minimum when the image is formed at infinity, and it is d by f. Magnifying power at least distinct vision is 1 unit more than that at infinity. If lens is kept at a distance a from the eye, then magnifying power can be calculated with the formula. This is only for competition exams to be used, 1 plus d minus a by f or d minus a by f for infinity. Compound microscope that has two lenses, two convex lenses in it. As you can see into the figure, the objective lens has lesser aperture or diameter as compared to the eye lens, the lens towards the eye. Eye lens, also known as ocular. Eye lens is also known as ocular. The binocular has two eye lens. That is why it is called binocular. Two converging lenses called objective and eye lens. Focal length of the eye lens, that is the ocular, is more than the focal length of the objective, and as visible in the figure, the diameter or the aperture of the eye lens or the ocular is more than diameter of the objective. The final image formed is at least distance of distinct vision, and it is magnified image being formed. Maybe it is between the two lenses or it is outside the two lenses, but it has to be at 25 centimeter from the human eye. The formulas has the terms U naught, V naught, UE, VE, F naught, and FE. O or naught means the object. E means for the eye lens. O means for the objective. E for the eye lens. U and V, you know, they are the distances of the object and distances of the image. And FO is focal length of the objective, and FE is the focal length of the eyepiece. The formula for magnifications are mentioned over there. It is V naught by U naught, bracket mein 1 plus D by FE. But always remember, when you get maximum magnification, there is a modification in the formula. V naught is replaced by the length of the tube, the distance between the two lenses, and U naught is replaced by the focal length of the eye lens. Sorry, focal length of the objective lens. Resolving limit and resolving power, the formulas you should remember, whereas this is not a part of the curriculum of CBSE for this particular session, so I have only mentioned the formulas. And yesterday also I told you, please don't at all believe in the deleted portion system. Anything from that on basic nature can be asked for. Details are omitted. The basics are not skipped anywhere. The sample paper shows it that questions from the basics are there from the deleted portion in it. So please be aware of that. Astronomical telescope, the telescope that we use to see heavenly objects or objects in the outer sky. Focal length of the eye lens is less than the focal length of the objective, and the diameter of eye lens is also less than the diameter of the objective. Here, the variation is much larger as compared to the microscope. Microscope में ये variation या gap बहुत कम होता है. Telescope में the difference is much more. The image formed here again is real, inverted, and smaller. That means if I use an astronomical telescope to look at Mars or Venus, मुझे वो उल्टा दिखाई दे रहा है, upside down दिखाई दे रहा है. Magnification is given by minus FO by FE. FO is focal length of objective, FE is focal length of eyepiece, and capital D is distinct of distinct vision. If image is formed at least distance of distinct vision, it is minus FO by FE 1 plus FE by D. And if it is at infinity, it is minus FO by FE. Terrestrial telescope, it has one more third lens in between erecting lens, whose purpose is to invert the image. That means to let us see the image non-inverted or erect. The magnification is given by the formula shown. माइनस साइन हट गया एस्ट्रोनॉमिकल से और कुछ भी चेंज नहीं आएगा. गैलीलियन टेलीस्कोप केवल वेरी इंट्रोडक्टरी फॉर्म में हमारे करिकुलम में है. मैंने भी खाली फॉर्मूला वही यहाँ पे दे रखे हैं. इट इज अ कॉम्बिनेशन ऑफ अ कॉन्केव एंड कॉन्वेक्स लेंस. Resolving power and resolving limit are shown over there. This very important part, the lower part over here, if we are given a very common questions in the past in MCQs or 1 mark questions, if we are given 4 convex lenses of focal length f1, f2, f3 and f4 in decreasing order, which 2 should be used for making a telescope and which 2 should be used for making a microscope? As I told you just now, for a telescope, the variation between the focal length is much more. That means f1 and f4, the 2 extremes, should be used for making a good telescope. And that also we discussed that the objective has higher focal length. So f1 would act as the objective lens and f4 would act as the eyepiece. For the microscope, the 2 are not having much gap. So the possible pairs are f1, f2, f2, f3, f3, f4. Objective has higher focal length. So if it is f1, f2, then, the objectives are of lower focal length than it. So if it is f4, f3, that should be used because we require minimum possible focal length for a microscope. f4 would be the objective and f3 would be the eyepiece. A very few questions I have taken from this as well. A man can see the objects up to a distance of 1 meter from his eyes. For correcting his eyesight so that he can see an object at infinity, he requires to use the lens of what power? Man can see objects up to a distance of 1 meter. That means it is myopia. He's not able to look at far off objects properly. And that means the answer has to be with a negative power. D is my answer. No need to solve the question because all the 3 are positive. But even if you want to, you have to simply use the lens formula 1 by V minus 1 by U is equal to 1 by F. The given length 1 meter or 100 centimeter. You have to use it as V. You have to use infinity as U. V is minus 100, U is minus infinity. Substitute the values, you will get F as minus 100. Reciprocal of it in meters is the power minus 1D. A man can see clearly up to 3 meters only. A lens for his spectacles so that he can see clearly up to 12 meter. I don't think there is any need to explain it again. The same logic, the focal length would come to be minus 4 meter, reciprocal of it, minus 1 by 4 diopter is the power needed. The diameter of the eyeball of a normal eye is about 2.5 centimeter. It's 2.48 centimeter to be very accurate. The power of the eye lens varies from an eye sees distant objects with full relaxation. So, power for looking at far off objects is 40D. For minimum, it has to be at 25 centimeter. You can use the formula 1 by V minus 1 by U is equal to 1 by F is being used. Focal length in this case would be reciprocal and of 40 plus 4 and you will get the power as 44 diopter. The resolution limit of eye is 1 minute. 1 minute means 1 by 60 second. At a distance of r from the eye, two persons stand with a lateral separation of 3 meters. For the two persons to be just resolved by the naked eye, R should be 10 kilometer, 15 kilometer, 20 kilometer, and 30 kilometer. Sorry, Mr. Siddharth MV is over there in the chat box and he's just asking to mention his name over here. I have mentioned it, Siddharth. All the best for your exams. Coming back to the question, the resolution limit of eye is 1 minute. At a distance of R from the eye, two persons stand with a lateral separation of 3 meters. For the two persons to be just resolved by the naked eye, angle of minimum resolution is being talked of. R should be 10 kilometer, 15 kilometer, 20 kilometer, or 30 kilometer. Just look at the figure. What does resolving power or resolution limit means? We are talking about the minimum angle needed so that we can identify the two objects distinctly or individually. You might have observed that as you look at two objects at far off distance, if you start moving away from it, they start appearing to be merged objects. So the minimum angle of vision needed for the two objects made at your eye to identify them distinctly. From the figure, if I simply use the formula L is equal to R theta over there, L is D, 3 meter, R is to be calculated, theta is given as 1 minute, that is 1 by 60 second. Convert into radians, 1 by 60 into pi by 180 number of radians, and substitute to get the value of R as 10 kilometer. It would come to be for you as 10,000 meter, as you are using 3 meter over there, and it would be then written as 10 kilometer as your final answer. 2 points separated by a distance of 0.1 millimeter, that is 0.1 millimeter, 1 into 10 to the power minus 4 meter, can just be resolved in a microscope. Resolving power of a microscope is being talked of. When a light of wavelength 6,000 angstrom, 6,000 into 10 to the power minus 10 meter is used, if the light of wavelength 4800 angstrom, that is 4800 into 10 to the power minus 10 meter, is used, what would be the new limit of resolution? Limit of resolution is directly proportional to lambda. If you look at the formulas in the case of microscope and telescope I mentioned previously, then the ratio of resolution limits would be the ratio of wavelengths. So RL1 by RL2 is equal to lambda 1 by lambda 2. Substitute the values of RL and lambda. No need to convert it into meters over here because it is a ratio purpose. Millimeter by millimeter and angstrom upon angstrom is applicable. The units would get cancelled. So it is no need to convert the units over here. And you'll get the value of RL2, resolution limit in the second case, when the wavelength is 4800 angstrom, to be 0.8 millimeter. If a compound microscope, for compound microscope, the focal length of two lenses are 1.5 centimeter and 6.25 centimeter respectively. An object is placed at 2 centimeter from the objective. Final image is formed at 25 centimeter, that is capital D, distance of distinct vision. What should be the distance between the two lenses? There is the length of tube. Length of tube is generally given by the formula mentioned over here, U naught F naught upon U naught minus F naught. Naught means objective, plus FED upon FE plus D. E means the eye length. Substitute the values and you get the value of LD, the length of tube, as 11 centimeter. You can note down this formula for further reference. It will be of much use in MCQs, but not to be mentioned in theoretical questions. Please make it very clear. This is nowhere mentioned in NCERT. So these formulas that are nowhere talked of even in NCERT should not be used in theoretical exams. The focal lengths of the objective and eyepiece of a compound microscope are given as 2 centimeter and 3 centimeter respectively. Just look at it, how small values they are. The distance between the objective and the eyepiece is 15 centimeter. The length of tube is 15 centimeter. The final image formed by the eyepiece is at infinity. the two lenses are thin. The distances in centimeter of the object and the image produced by the objective measured and the object from the objective lens. We know that given in the question is f of objective is 2 centimeter, f focal length of the eyepiece is 3 centimeter, and L is 15 centimeter. By using the formula, L, that is length of tube, is equal to V naught plus Fe. If you look at the figure of the compound microscope, the length of the tube is always equal to VO, that is the distance of first image formed from the objective, and FE, the focal length of the eyepiece. From this you can get the value of V naught as 12 centimeter, and we know that V naught by U naught is equal to V naught minus F naught by F naught. Substitute the values and get it as U naught. The focal length of the objective and the eye lens of a microscope are 1 centimeter and 5 centimeter respectively. If the magnifying power for the relaxed eye is 45, then the length of tube is a very straightforward formula. Magnifying power is given by length of tube minus F naught minus Fe upon F naught into Fe. One more formula for direct MCQ answers only. Substitute the values and you can get the answer length of tube as 15 centimeter. If the focal length of objective and eye lens, they are given as 1.2 and 3 centimeter respectively, and object is at 1.25 centimeter from the objective lens. Final image now is at infinity. Till now we were talking of final image at least distance of distinct vision and then the magnifying power. The formula was reduced to this over there, and substituting the values straight in the formula minus F naught upon U naught minus F naught into D by Fe. This U naught minus F naught, I remind, is equal to V naught. And you get it as minus 200 as the magnifying power. Magnifying power of an astronomical telescope is 8. Distance between the lenses, that is length of tube, is 54. The focal length of the two lenses would be, magnifying power is F naught by Fe. Magnifying power is given as 8. And distance between the tubes is given as 54. So if L is F naught plus Fe, then we can get the values of F naught and Fe in either of the terms and substitute it into M naught. Let it be M naught is equal to F naught upon 54 minus F naught. You can solve it to get the value of F naught as 6 centimeter, and thus Fe would be 54 minus 6, that is 48 centimeter. The diameter of the moon is 3.5 into 10 to the power 3 kilometer, and distance of Earth and moon, that is 3.8 into 10 to the power 5 kilometer. If it is seen through a telescope whose focal length for the objective and eye lens are 4 and 10 centimeter, what is the angle subtended by the moon on the eye? Magnifying power is F naught by Fe or beta by alpha as we did. If I just look at the question, what is the magnifying power that we can get? F naught and Fe are given 4 meter and 10 centimeters, so it comes to be 400. Beta upon alpha, it comes to be 40. So beta is equal to 40 alpha. Substitute the values. Beta is equal to 40 alpha. Alpha is given to you, the ratio of 3.5 and 3.8 into 10 to the power 2. So it comes to be 20 degree. If I convert, the answer would be appearing in radians, and you will have to convert it into degrees by multiplying it by 180 upon pi. The answer in degrees would be 20 degree. A man is looking at a small object placed at his least distance of distinct vision, that is at 25 centimeter. Without changing his position and that of the object, he puts a simple microscope of magnifying power 10x and just sees the clear image again. The angular magnification obtained is, angular magnification is given by beta by alpha or tan beta by alpha. that is I by O would be the end result, and we know that it is V by U. Nothing to be seen over here. V by U, angular magnification here appears to be 1. Look at the question clearly. Clear image with 10x magnifying power, that is angular magnification appears to be 1 in this case. So this is all for the day. Thank you very, very much. If you people have any sort of concern or questions to be asked, you can just WhatsApp me up. My number is 77370. If you want to, you can note it down. 77370 So,
ओके, थैंक यू सो मच हितेन सर। डेफिनेटली आज का सेशन भी हमारा बहुत अच्छा गया है और निश्चित रूप से बच्चों को आपने जिस तरीके से ऑप्टिक्स के जो है डिफरेंट कॉन्सेप्ट्स को एक्सप्लेन किया है, बच्चों के लिए बहुत हेल्पफुल रहेगा। और बच्चों से भी मेरी रिक्वेस्ट है कि सर ने जो अपना नंबर दिया है, इफ़ यू फील एनी प्रॉब्लम यू कैन डायरेक्टली कॉन्टेक्ट टू हितेन सर। ही इज़ अ वेरी नॉलेजेबल पर्सन इन द फील्ड ऑफ फिजिक्स। तो आप सर से डायरेक्टली कांटेक्ट कर सकते हैं, फिजिक्स के जो भी डाउट्स होंगे उनको क्लियर कर सकते हैं। और इन फ्यूचर भी सर जो है जो डिफरेंट और हमारे जो चैप्टर्स आगे के जो चैप्टर्स हैं उन चैप्टर्स को लेकर भी सर हमारे साथ यहाँ पर उपस्थित होंगे। और फीडबैक फॉर्म या सर ने अपना नंबर भी इस पे डाल दिया हुआ है, मैंने इसको हाईलाइट किया हुआ है, स्क्रीन पे आप देख सकते हैं 7737003227। तो आप सर से डायरेक्टली कांटेक्ट कर सकते हैं। फीडबैक फॉर्म मैंने फीडबैक लाइव चैट बॉक्स में डाल दिया है, आप फीडबैक जरूर कर दें और हमारे साथ इसी तरह जुड़े रहिए। अभी थोड़ा सा चूँकि फेस्टिव सीज़न है, कुछ सेशंस हमारे शेड्यूल्ड हैं, बट फेस्टिव सीज़न की वजह से कुछ आगे पीछे हो रहा है। कल हम लोग कल परसों 6 को हम लोग मैथमेटिक्स का चैप्टर 2 जो है वो डिस्कस करेंगे शाम को 5 से 6। टाइम का ध्यान रखें, टाइम चेंज हुआ है। पर्टिकुलरली 6 तारीख के सेशन के लिए 6 को हमारा जो सेशन होगा वो 5 to 6 PM में होगा। और हमारे साथ डॉक्टर अजय होंगे पिलानी से मैथमेटिक्स का चैप्टर 2 डिस्कस करने के लिए। और एक बार फिर से वन मार्क सोल्यूशन की तरफ से, हमारे सभी व्यूवर्स की तरफ से, हमारे आज के रिसोर्स पर्सन हितेन परमार सर का बहुत बहुत धन्यवाद, बहुत बहुत आभार कि उन्होंने अपना वैल्यूएबल समय निकाला और हमारे साथ जुड़े। सर बहुत बहुत धन्यवाद आपका।
थैंक यू सर, थैंक यू वेरी मच।